Hello everyone. Today's session is regarding maximum power transfer theorem. Maximum power transfer theorem. This is the statement. The maximum power is delivered from a source to a load when the load resistance is equal to the source resistance. If we consider an electrical network, in order to transfer the maximum possible power from the source to the load should satisfy this condition. The maximum power is delivered from a source to a load when the load resistance is equal to the source resistance. Then we are going to prove of the theorem. Let's consider a simple circuit like this. A voltage source, then a series resistor Rs and load resistor RL. Current flowing through the circuit is I. From this circuit we can write I is equal to E divided by Rs plus RL. And power delivered to the load. Power delivered to the load resistor RL is equal to, we can write it as power delivered is equal to I square into R. Power is equal to I square into R. Current, this is our load. And power delivered to this load is I square into R. That is equal to I square, value of I is this one. So it is I square is V square divided by Rs plus RL square into RL. This is the power delivered. Now we got the mathematical expression for power delivered to the load. Now we have to find out the condition for which this power delivered becomes maximum. So in order to determine the value of RL, for maximum power to be transferred to the load, it should satisfy this condition. Derivative of P with respect to RL is equal to 0. This is the condition for maximum power transfer. So our aim is to find out the value of RL for which this power becomes a maximum. Now to get that maximum, differentiate this expression with respect to RL and equate it into 0. Determine the value of RL for maximum power to be transferred to the load, dP by dRL equal to 0. That means d by dRL of P. Substituting the value for P. P is V square RL divided by Rs plus RL square. Equal 0. So V square into d by dRL of RL by Rs plus RL the whole square is equal to 0. Now we have to differentiate this term. V square into d by dRL of denominator into derivative of numerator minus numerator into derivative of denominator. That is 2 into Rs plus RL. Divided by denominator square. Rs plus RL is equal to 0. Now we can write Rs square plus RL square plus 2 Rs RL minus 2 Rs into RL, open the bracket, minus 2 into Rs into RL minus 2 RL square divided by this term equals 0. Two Rs RL will cancel each other. So we will get Rs square minus RL square equal to 0, which means Rs is equal to RL. So in order to get maximum power, the value of load resistor RL should be equal to the series resistor Rs. This is the condition for maximum power transfer. So in order to get maximum power, the value of this RL should be equal to this resistor value, source resistor Rs. This is maximum power transfer theorem. Hence we can say that the theorem is proved. Next is steps to be followed in maximum power transfer theorem. If we are given with a network, first thing is to remove the variable load resistor RL. First, remove load resistor from the circuit. Then find VTH across the terminals A and B. Thevenin voltage should be found out between terminals A and B. Then find the Thevenin resistance RTH as seen from points A and B. Then find the resistance RL for maximum power transfer. Now to get maximum power transfer, RL should be equal to RTH. That we have already derived. RTH is the Rs in the previous circuit. Fifth one is find the maximum power. And we know that in a circuit, IL is equal to VTH divided by RTH plus RL. That is equal to VTH divided by RL. If RL equal to RTH, this term will change to 2 times RTH. Now, let's write the expression for maximum power, Pmax. When RL is equal to RTH, power delivered will be maximum. So, we can write Pmax is equal to IL square into RL. IL is current through this load, the square into RL will be the maximum power. That is equal to, substitute for IL. So VTH square by 4 RTH square into RL. RL is again same as RTH. This is equal to VTH square divided by 4 times RTH. This is the maximum power transferred. VTH square divided by 4 into RTH. Let's consider a problem. For what value of R in the given circuit will it receive the maximum power? Find the maximum power. This is the resistor R. So we have to find out the value for R in order to get the maximum power. First step is calculation of Thevenin voltage VTH. And to calculate VTH, the load resistor is removed and the terminals are kept open. Now, voltage across these open terminals is the Thevenin voltage VTH. Now we have to find out this VTH. This current is taken as I, which current I1. the circuit we can write I1 is equal to VTH divided by 2 plus 2. This number is this is V. 12 by 2 plus 2. So I1 is 3 amperes. And from this circuit we can write Thevenin voltage VTH is equal to voltage across this resistor. That is I1 into 2. That is 3 into 2, 6 volt. So we got VTH is equal to 6 volt. Next step is calculation of RTH. In order to get RTH, the voltage source is replaced by a short circuit. Independent source is replaced by a short circuit. And terminals P and Q kept open circuited. Then draw the remaining. RTH is the resistance between these two terminals. And from the circuit it is clear that RTH is equal to 2 parallel to 2. That is equal to 2 into 2 by 4. That is 1. Then third step is find the maximum power. Maximum power P max is equal to equation for P max is VTH square divided by 4 RTH. That is equal to 6 square divided by 4 into 1. So 9 watts. This is the maximum power. Then this one also we have to find out value of R in the given circuit will receive the maximum power. So it received the maximum power at, so in order to get maximum power, RL should be equal to RTH, that equal to 1 ohm. So when RL is equal to 1 ohms, maximum power will be delivered to the load. Now let's consider another question. Find the value of R for maximum power to R. Determine maximum power to R for the given network. So first step is to calculation of V. Before that, I am redrawing the same circuit. 20 volt source, then 20 volt source to a 5 ohm resistor. This 5 ohm resistor, this point, this terminal. From there, another 5 ohm resistor to terminal A. So we have already drawn these two resistors. Now from this terminal, that means from here, a 5 ohm resistor to negative terminal of 20 volt. So that 5 ohm, another terminal of that 5 ohm is connected to negative terminal of this 20 volt source. Then from A, we are having the resistor R. Okay, R is drawn. Second terminal of R is B. B is connected to here or to the negative of 20 volts. So the circuit can be redrawn like this. Now let's calculate VTH. In order to calculate VTH, the circuit is redrawn like this. Terminals A and B are kept open circuited. Open, and voltage between A and B is Thevenin voltage VTH. Now we have to find out this VTH. And from the diagram, it's clear that the entire current will flow through this path only. No current will flow through this path. So we can say that terminal voltage across this 5 ohm resistor is exactly same as VTH because no currents flows through this 5 ohm resistor. So this potential and this potential will be same. Anyway, this current is taken as I, I1. Now we can write I1 is equal to 20 divided by 5 plus 5, 2 amperes. Then VTH is equal to voltage drop across this 5 ohm resistor, that is I1 into 5. So 2 into 5, 10 volt. So we got Thevenin voltage as 10 volt. Next is the calculation of RTH, Thevenin resistor RTH. For that, replace the independent voltage source with a short circuit. Then 5 ohm. This is a 5 ohm. This is terminal A. This is terminal B. And B kept open circuited. This is 5 ohm. Now we have to calculate RTH. RTH is the resistance between terminals A and B. Look from here. It is clear that RTH is equal to this 5 and this 5 are in parallel. So 5 parallel to 5, that in series with this 5 ohm. So 5 parallel to 5, we will get it as 2.5 plus 5 is equal to 7.5 ohms. RTH is 7.5 ohm. Now let's draw the reduced circuit or the Thevenin equivalent circuit. Thevenin equivalent circuit, Thevenin voltage we got as 10 volt. Thevenin resistance we got as 7.5 ohms. And between A and B, draw the load resistor R, RL. Now the maximum power is transferred through the load resistor only when load resistance equals Thevenin's resistance. So for maximum power transfer, RL should be equal to RTH. That we got as 7.5 ohms. So according to maximum power transfer theorem, value of RL should be equal to 7.5 ohms only when maximum power will be transferred from source to the load. The next step is to calculate the maximum power P max, and we know the relation P max is equal to VTH square divided by 4 into RTH. That is equal to 10 divided by 4 into 7.5. We will get it as 3.33 watts. This is only for today's session. Thank you.